Hello and welcome to The Rabbit Hole, the Definitive Developers Podcast, live from the Buggy Down Bronx. I'm your host, Michael Nunez. Our co-host today,
Dave Anderson.
And our producer,
William Jeffries.
And today, we're going to talk about the Liscov substitution principle.
Yeah, there is no Liscov substitute for you, William. We've tried.
You need to, we miss you, man. How's it going?
Thanks, guys. You're so solid.
We're just trying to be like you, bro. If you noticed, we've been starting on the solid or the so part of solid. We got a couple of interviews in here and there that we wanted to release. So we're going to try to capture down the lid part in solid, but expect more interviews. So we'll hopefully be able to spell out an entire word within the next couple episodes.
It's like Game of Thrones cross Wheel of Fortune. You're just like, oh god, or Dragon Ball Z cross Wheel of Fortune. Like, what's the next letter?
So if people are in suspense for the next letter, we apologize. They'll come soon. Trust us. But today we're talking about the L, which is the Liscov substitution principle.
Yeah. Oh my god, Liscov just sounds like a mad scientist, right?
Yeah. Who did you think Liscov was when you heard Liscov principle?
Some Russian from the 18th century in a dusty library. I don't know.
Yeah, I definitely thought like an old dead mathematician.
Yeah, I had a math guru in my head, and given the definition that you would find in Wikipedia, would definitely allude to the crazy dead mathematician. I'm going to try to read this in one breath because it's a mouthful. Here it goes. If S is a subtype of T, then object of type T may be replaced with objects of type S, i.e., an object of type T may be substituted with any object of a subtype of S without altering any of the desirable properties of the program, correctiveness, task, perform, etc. What was that?
It's a science. That's what that is, Mike.
Yes. It definitely is science. And I know we were talking about mad scientists, dead mathematicians, but this principle actually comes from a Barbara Liskov, who still alive. Liscov lives, and she is an American computer scientist.
Yep. From the 1987 conference keynote address titled Data Abstraction and Hierarchy. Just reading off Wikipedia over here. Like, not gonna lie. But yeah, it was kind of interesting. This is actually like a principle, a very hard computer science principle that was first spoken about by Barbara Liskov and then joint published with Jeanette Wing.
Yes, she got her Turing Award for introducing the Liscov substitution principle, and she was one of the first women to be granted a doctorate in computer science in the United States, which is awesome. So thank you for your work, Ms. Liskov. And we're going to get right to this solid piece because I said a lot.
Yeah, it did go a little bit over my head. Maybe we could do another take on like...
Do you want to try? Or I said a lot. I'm out of breath right now.
Yeah, I could give it a shot. So there's another definition here, which is that objects in a program should be replaceable with instances of their subtypes without altering the correctness of the program. That was easier.
A lot nicer.
A little easier.
It was a lot nicer, yes.
Let me,
and the first one is definitely a whole lot of math.
All right, let me see if I can explain this in plain English. I think the idea here is that you should be able to swap subclasses in for each other. So for example, if you have a bunch of shapes, like a triangle and a rectangle and a square, and they all inherit from a shape class, then you should be able to, anywhere that you could use a rectangle, you should also be able to replace that with a triangle and have everything work. So let's say you have an area method that's defined on the shape class. Well, triangle needs to implement an area method and rectangle needs to implement an area method and so forth. It's like an interface in Java or duck typing in Ruby.
Yeah, I think more specifically, it's like if I expect that you're going to give me a shape, then a circle, a triangle, whatever should do the things that a shape says it's going to do in a consistent way.
Right. So if every shape is going to have a perimeter method and an area method, then It doesn't really matter how those methods are calculated. It could be that the square, it's the side squared, and for a rectangle, it's 2L plus 2W or whatever. Actually, that would be the perimeter, but whatever. As long as the method has the same signature, then you're fine. You wouldn't want to try and pass in the values that need to be present to do the calculation, because that's going to be different for every shape.
William, you're an excellent programmer, and I believe what you did was the right thing in making square and rectangle and triangle inherit from shape. But the problem is that a lot of people, and I think Dave mentioned earlier before the recording that it was a heated argument to determine whether a square is a rectangle, because some people would mention that a square is a type of rectangle, but when you actually implement it programmatically, that may not be the case, because a square, in order to draw a square or the area of a square, you only need one side because every side is the same, as opposed to a rectangle where there are two separate sides. So the question is a rectangle a violation of the LSP principle?
I feel like either approach is right, but it depends on your context. And that's kind of why, like, the designers of Go were like, you don't get OOP. We're taking this away from you. You don't get inheritance. You only get interfaces, because otherwise you're just going to ruin it.
Yeah, I think
don't ruin this for us.
Inheritance is nice if used with caution. You sprinkle that in lightly. You don't want like 7 layers of inheritance. And I think that's what happens if you're like, oh, yeah, well, a square is a rectangle, so the square should inherit from rectangle, and then rectangle inherits from shape. Because then it's like, well, I mean, a rectangle is a polygon. Should we have square inherit from rectangle, inherit from polygon, inherit from shape?
Oh, no.
How deep do we want to go? I mean, it's a parallelogram.
I feel like I've worked in this code base before, and I tried to refactor it, and I cried. It broke me.
Yeah, so I'm pretty hesitant to use inheritance unless you have like a very straightforward inheritance pattern where you only have one layer of inheritance and you have one clear superclass and then just a handful of subclasses that are going to inherit from it. So if you know you're really just going to have maybe like 6 or 7 of these, I think inheritance can make sense. But if you can't come up with a good justification for why the hierarchy is going to work this particular way and not some other way, then I think you're swimming in dangerous waters.
Yeah, I've definitely seen like inheritance used in languages like Python, where they allow multiple inheritance, but they don't have a formal concept of an interface, or at least they didn't for a long time. So they would just use that as a way of defining what your structural subtype was, what your interface actually was, and what you needed to implement, and force you to do it. But yeah, besides that, just run.
Just be careful. If you're able to swap them out, then do so. That whole math monologue that I mentioned before, it's simply just if you're able to replace one subtype for another without breaking your code or causing it to do some form of exception, then you're probably violating the Liscov substitution principle, or as I called it, the LSP, because I guess we got to keep it cool and hip.
Right.
That's what all the cool kids are saying.
Yeah. Don't violate the LSP, bro. Watch out for that LSP.
It's like an after-school special. Oh, no, Bobby. Exactly. Bobby, don't violate LSP.
Don't do it, bro. I told you what'll happen.
Just peer pressure.
Exactly. Just think about your objects and inheritance and don't violate it. That's all. That's all we're asking for.
Does anybody miss interfaces?
Do we miss them?
Yeah, like if you're in a language that doesn't support interfaces, do you miss them?
I haven't thought about them in a while.
I feel like
I'm in JavaScript view land right now and doing some Rails backend. Haven't really.
You're like kind of like in framework land, right? Where it's like you're in a box. I think it's good when you're going off into like service code territory where you're trying to extract something out. And if you can at least think about what the interface is and name it, then I think that's a pretty powerful thing. Because that way you can try and keep it consistent. Because with a duck type language, it's totally possible that your duck might, instead of quacking, return 42 or something like that.
Oh, no.
And that might be kind of disastrous.
I think I kind of miss interfaces if I'm in a strongly typed language. But if types are not getting enforced, then it doesn't really seem like it adds a lot of value in my life. It's not a thing that I reach for or wish I had.
What are you typing in these days? What language framework are you using?
So TypeScript on the front end, which I like my interface, and then Ruby on the back end. And I don't miss it.
You're not using sorbet.
No.
TypeScript is pretty intense. People write in TypeScript, if S is a subtype of T, they're like way into it. All those parameterized types, you can get pretty crazy defining those types.
I take it, William, you're not going crazy with the types in TypeScript?
No.
It's any everywhere.
I always feel guilty when I use any, but it's just so much easier.
Yes.
Just keep it simple, I guess, sometimes.
Well, so I'm working in a code base that was originally JavaScript and got converted to TypeScript. I think if you start off with TypeScript, you can be really Puritan about it and enforce that nobody uses the any type. But when half your code base is still in JavaScript, it's going to be a bad time. You're going to have a bad time.
JavaScript is any type all around, and you just deal with it. But yeah, I think TypeScript is probably a good example of when you're able to enforce like the LSP across your code base, because you can definitely go extremely specific with the types and subtypes of what and whatnot.
Yeah, but even if you are in a frameworky land where there are any types, like in JavaScript, like you have a React component that has some interface, sometimes it's kind of powerful to think about similar kinds of components having the same interface. If they all take the same props, then one can be swapped in the place of the other, maybe, and dynamically change the user experience. I've often seen that with like different types of modals and things like that.
Oh man, those modals and those frameworks, they're everywhere. But yeah, be mindful when you're figuring out what types are going to exist in the code base and ensure that your inheritance is being used properly if you're using inheritance or if you're just duck typing the whole way through. Don't violate the LSP. Do yourself a favor.
Be cool.
Follow us now on Twitter at Radio Free Rabbit so we can keep the conversation going. Like what you hear? Give us a 5-star review and help developers just like you find their way into the rabbit hole. And never miss an episode. Subscribe now however you listen to your favorite podcast. On behalf of our producer extraordinaire, William Jeffries, and my amazing co-host, Dave Anderson, and me, your host, Michael Nunez, thanks for listening to The Rabbit Hole.